Hello everyone! In this video, you will learn how to find the domain of a function. Example 1. Find the domain of fx equal to x plus 4. X plus 4 is a polynomial. Polynomials are sums and differences of polynomial terms. It must contain, number 1, no square roots of variables. Number 2, no fractional of variables. Number 3, no negative powers on the variables. Number 4, no variables in the denominator of any fractions. The domain for a polynomial is always set of all real numbers. Either you write in full sentence all real numbers, or you write the real number symbol R, or you can write in interval notation minus infinity, comma, plus infinity. Just choose one. Example 2. Find the domain of fx equal to x squared plus 4x plus 5. This is a polynomial. It does not contain any square roots of variable. It does not contain any fractional of variable. It does not contain any negative powers on the variable. And it also does not contain any variables in the denominator of any fractions. Since this is a polynomial, the domain is all real numbers. Again, you don't have to write all three, just choose one. Either you write in full sentence, all real numbers, or you just write the symbol R for real numbers, or you can write in interval notation minus infinity, comma, plus infinity. Example 3. Find the domain of fx equal to 4. This function only have plain number, no variables. Let's check. It does not contain square root of variables. It does not contain fractional of variables. It does not contain negative powers on the variables, and it also does not contain any variables in the denominator of any fractions. So, a plain number is also a polynomial. Hence, the domain is all real numbers. Example 4. Find the domain of fx equal to 1 over 4. This is a plain number. But now you have a fraction. Is this a polynomial? Let's check. It does not contain square root of variables. Number 2, it does not contain any fractional of variable. So, even though this is a fraction, but it does not contain any fractional of variables. So, this is also a polynomial. The domain of the function is all real numbers. Example 5. Find the domain of fx equal to minus square root 3. This is a negative number. It contains square roots of numbers, but not square root of variables. So, this is also a polynomial. Therefore, the domain is all real numbers. Example 5. Find the domain of fx equal to 0. 0 is a plain number. Therefore, the domain is all real numbers. Example 7. Find the domain of fx equal to x cubed minus 5. This is a polynomial. So the domain is all real numbers. Example 8. Find the domain of fx equal to 2 over x plus 3. This is not a polynomial. Because it has variables in the denominator of a fraction. In order for this function to exist, the denominator cannot be 0. So you write x plus 3 not equal to 0. Minus 3 from both sides, you get x not equal to minus 3. Hence, the domain is all real numbers except for minus 3. Or you can write R slash set notation minus 3. Or you can use interval notation minus infinity minus 3. The parenthesis means open interval. It means that it does not include minus 3. Union means plus. Open interval minus 3, comma, plus infinity. It means that it includes all real numbers except for minus 3. Example 9. Find the domain of fx equal to 2 over x squared plus 3. This is not a polynomial because it contains variables in the denominator of a fraction. In order for this function to exist, the denominator cannot be 0. So, x squared plus 3 cannot be 0. X squared cannot be minus 3. But x is not equal to square root of minus 3, and this is undefined. It means that you cannot find any real numbers that makes the function undefined. Therefore, the domain is all real numbers. Example 10. Find the domain of fx equal to square root x plus 3. This is not a polynomial because it contains square root of variables. A square root cannot accept negative numbers. Hence, the term x plus 3 inside the square root must be greater than or equal to 0. Subtract 3 from both sides, you get x greater than or equal to minus 3. So, the domain is all real numbers greater than or equal to minus 3. Or in interval notation, you write minus 3, plus infinity. Please notice that now you have square bracket. It means that you have to include minus 3 and all the numbers greater than minus 3. Example 11. Find the domain of fx equal to square root x squared plus 3. This is not a polynomial because it contains square root of variable. So now, everything inside the square root should be at least 0. You have now x squared greater than or equal to minus 3. So, x is greater than square root minus 3, which is undefined. It means that you cannot find one number x that makes the function undefined. Therefore, the domain is all real numbers. Example 12. Find the domain of fx equal to square root x squared plus 2x minus 8. Everything inside the square root must be at least 0. You factorize x squared plus 2x minus 8. In order to factorize x squared plus 2x minus 8, find the factor of 8. So you have 1 and 8. 1 times 8 is equal to 8. And also 2 and 4. 2 times 4 is equal to 8. For 1 and 8, 8 minus 1 is equal to 7. 8 plus 1 is equal to 9. And it does not equal to 2. Why you need 2? Because the middle term is 2x. The second factor is 4 times 2. 4 plus 2 is 6. Not the correct answer. 4 minus 2 is equal to 2. So, you have x, sum symbol, 4 times x, sum symbol, 2. Now, you want to determine whether plus or minus. Have a look at number 8. The sign for number 8 is negative. What you need to do to get a negative number is to multiply positive and a negative numbers. The question is, which one is positive and which one is negative? Have a look at 2x. The sign is positive 2. So if the sign is positive, so the larger one should be positive and the smaller one should be negative. Hence, you will get x plus 4 times x minus 2 because 4 is larger than 2. 4 minus 2 is 2. In order to solve this, you need to find a positive number because x plus 4 times x minus 2 is greater than or equal to 0. Hence, either you have positive times positive or negative times a negative number. Therefore, you have x plus 4 greater or equal to 0 and x minus 2 greater or equal to 0 for the case of positive times positive. It means that x is greater than or equal to minus 4 and x also should be greater than or equal to 2. The intersection of these two means that x should be greater than or equal to 2. Or if you write in interval notation, you have square bracket 2. It means that you include 2, comma, plus infinity. It means that any number after 2. The second case is x plus 4 is less than or equal to 0 and x minus 2 is less than or equal to 0. This means that x should be less than or equal to minus 4 and x should be less than or equal to 2. The intersection of these two, you will get x should be less than or equal to minus 4. Or you can write in interval notation minus infinity minus 4. Because you have the equal sign, you need square bracket. Therefore, the domain is minus infinity minus 4 union 2 plus infinity. Example 13. Find the domain of fx equal to log x plus 3. For a log function, everything inside the bracket must be positive numbers only, because log cannot accept negative numbers and also 0. So you write x plus 3 greater than 0 without the equal sign. So x is greater than minus 3. Therefore, the domain is all real numbers greater than minus 3. In interval notation, you write minus 3 plus infinity. Please notice that now you don't use the square bracket because there is no equal sign. It means that it does not include minus 3. Because if you include minus 3, it will become log of a 0 and it is undefined. Example 14. Find the domain of fx equal to log x squared plus 3. A log function only accepts positive number. So you have x squared plus 3 greater than 0, x squared greater than minus 3. But here you will get x greater than square root of minus 3, and this is undefined. It means that you cannot find any number that makes x squared plus 3 become 0 or negative. Therefore, the domain is all real numbers. Example 15. Find the domain of fx equal to log x squared plus 2x minus 8. Log cannot accept negative numbers and 0. So you have x squared plus 2x minus 8 greater than 0. The next step is factorization. The factor for 8 is 4 and 2, so you have x sine of 4 and times x sine of 2. Since the sign for 2x is positive, you will get x plus 4 times x minus 2. Two cases. The first case is positive times positive. So x plus 4 is greater than 0 and x minus 2 greater than 0. X plus 4 greater than 0, you get x greater than minus 4, and for x minus 2 greater than 0, you will get x greater than 2. The intersection of x greater than minus 4 and x greater than 2 is x greater than 2. In interval notation, you write it as 2 positive infinity. The second case is negative times negative to get a positive number. So you have x plus 4 less than 0 and x minus 2 less than 0. Hence, x is less than minus 4 and x is also less than minus 2. The intersection of these two will give you x less than or equal to minus 4. In interval notation, you write minus infinity, comma, minus 4. Therefore, the domain is equal to minus infinity, minus 4, union, 2, infinity. Example 16. Find the domain of fx equal to 2 exponent x plus 3. For exponent function, the domain is all real numbers. Example 17. Find the domain of fx equal to square root of x plus 3 over x minus 2. For the numerator, x plus 3 must be greater than or equal to 0, where x is greater than or equal to minus 3. And in the denominator, x minus 2 must not equal to 0. So, x does not equal to 2. The intersection of these two will give you x greater than or equal to minus 3 intersects x does not equal to 2 equal to minus 3 2 plus 2 infinity. And that is the domain. Example 18. Find the domain of fx equal to x plus 3 over log x minus 2. For the numerator, the domain is all real numbers because x plus 3 is a polynomial. For denominator, first we have a look at log. For log function, x minus 2 should be greater than 0. So you get x greater than 2 equal to 2 positive infinity. Log itself cannot be 0 because it is the denominator. So log x minus 2 cannot be 0. Now we need to find x so that log become 0. Take exponent for both sides. 10 exponent log x minus 2 is 10 exponent 0. 10 exponent log x minus 2 is not equal to 10 exponent 0. So, x minus 2 is not equal to 1. And you get x is not equal to 3. It means that if you substitute x with 3, you will get log 3 minus 2 equal to log 1 equal to 0. This makes the denominator become 0 and the function will be undefined. What you need to do now is take the intersection of the domain for the numerator and the domain for denominator. The domain for denominator is 2, 3 union 3 infinity because 3 is not a domain. Intersect with all real numbers from the numerator, you will get 2, 3 union 3 plus infinity, and that is the domain. Example 19. Find the domain of fx equal to square root x plus 3 over x square minus 16. For the numerator, x plus 3 is greater than or equal to 0 because this is a square root, and x is greater than or equal to minus 3. For the denominator, x square minus 16 cannot be 0, so x cannot be plus minus square root 16. Remember, if you have even power, you should add plus minus. For example, x square equal to 16, you will have x equal to plus minus square root 16. And this is equal to plus minus 4. So the domain is x greater than or equal to minus 3 from the numerator, intersect x not equal to minus 4 and 4 from the denominator. So the domain is -3, 4, union 4 plus infinity. Thank you.